Hello students, welcome to your channel Learning Point. Today we are going to study higher order derivatives, which is a part of 12th Commerce new syllabus for the year 2020. Now what is the meaning of the higher order derivatives? It is derivative of a derivative. So it is called as a higher order derivative. Now what does that mean? If y is equal to fx is a function of x, then you know that dy by dx, which is equal to f dash x, is derivative of y with respect to x. This derivative of y with respect to x is actually the first order derivative of y. It is called as first order derivative because we have differentiated y only once. Now, when we differentiate this derivative for one more time, then it will give us the second order derivative. So let us see how we represent the second order derivative. In order to differentiate again, we have to say over here again differentiating with respect to x. So I will get derivative of dy by dx, which is equal to derivative of f dash x. And when I want to represent this derivative of dy by dx, it is denoted by d square y by dx square, and the second order derivative of f dash x is denoted by f double dash x. This is called as second order derivative of y, obviously with respect to x. Now let me help you with an example. If you have y is equal to log of 3x plus 1. So in such a case, what we do is differentiate with respect to x as usual. So derivative of y is equal to dy by dx. Derivative of log 3x plus 1 is obtained using the formula for log of fx. And what is the formula for log fx? It is 1 upon fx into derivative of fx, where this 3x plus 1 is considered as fx. So over here I get 1 upon 3x plus 1 multiplied by derivative of 3x plus 1. Now this 1 upon 3x plus 1 remains as it is. Derivative of 3x plus 1 is 3 into 1 plus the derivative of constant 1 is 0. So I just get 3 into 1. So finally this becomes 3 multiplied by 3x plus 1 to the power minus 1. Because I am applying the law of indices, 1 upon a raised to m can be written as a to the power minus m. If an element is transferred from denominator to the numerator, the power becomes negative. And here, since nothing was in the power, so I consider 1. So 1 becomes negative 1 over here. Okay guys. Now, when I want to find out the further derivative, second order derivative, I will say over here, again differentiate with respect to x. So what is the second derivative of dy by dx? It is d square y by dx square. This 3 is the coefficient, so we leave it as it is. And for this function 3x plus 1 to the power minus 1, I will use over here the formula fx to the power n, and the answer for that is n into fx to the power n minus 1 multiplied by derivative of fx. So in such a case, 3 into minus 1, 3x plus 1 to the power minus 2, and if I consider this as my fx, what is derivative of 3x plus 1? It is going to be 3 into 1 plus 0. So I get over here the final answer as minus 9, 3x plus 1 to the power minus 2. Just in case, if you wish to make the power positive, just take that element in the denominator. It will become 3x plus 1 whole power 2 is equal to d square y by dx square. Okay, now without wasting a lot of time, let us understand all the sums of exercise 3.6 of the textbook. Question 1 says, find d square y upon dx. So the sum number 1 over there is y is equal to root of x. So the first thing that I will do is I will express this as x to the power 1 by 2 and differentiate this using the formula for x raised to n. What is the derivative of x raised to n? N into x to the power n minus 1. Students, this is a part of the basics of the derivatives which I have covered in a previous video. You will get the link in the description box as well as on the right hand top corner. Please check out that video in order to learn all the other functions which are covered in the basics of derivatives. The formulas and all the basics have been covered over there. So over here, when I say differentiate with respect to x, derivative of y is dy by dx, which is equal to 1 upon 2 x to the power 1 by 2 minus 1, which is 1 by 2 x to the power minus 3 by 2. This itself is the value of dy by dx. But because we want to find the second order derivative, we will say over here, again differentiate with respect to x. Derivative of dy by dx is d square y by dx square. This 1 by 2 is the coefficient. So we'll leave this 1 by 2 over here as it is. 1 by 2 minus 1. Sorry, this has to be minus 1 by 2. Then after that, minus 1 by 2, x raised to minus half minus 1, minus 1 by 4. After taking LCM, it will become x to the power minus 3 by 2. Just if you wish to convert this power into positive, I write over here minus 1 upon 4 x raised to 3 upon 2. This is d square y by dx square. So that was the sum number 1, students. Now let us understand sum number 2. It is y is equal to x to the power 5. Again, in order to differentiate this, I will use the formula for x raised to n. Differentiating with respect to x, derivative of y is dy by dx. And this is 5 into x to the power 5 minus 1, which is 5 into x to the power 4. In order to find the second order derivative, we will say again differentiate with respect to x. So derivative of y, d square y by dx square, second order derivative I should say. This 5 is the coefficient, so we leave this 5 as it is. This becomes 4 into x to the power 4 minus 1, which is equal to 4x cube. So ultimately you get your d square y by dx square is equal to 20 into x to the power 3. Now, what can be more easier than this, guys? It's a very easy sum. In the similar manner, we are also having sum number 3. It says y is equal to x to the power minus 7. Again, I will use the same formula, derivative of x raised to n, in order to differentiate this. So I will say differentiate with respect to x. Derivative of y is dy by dx minus 7 x raised to minus 7 minus 1 minus 8. Now, in order to find the second order derivative, we will say over here again differentiate this with respect to x. So derivative of dy by dx is d square y by dx square, and minus 7 is the coefficient, so we leave this, and it is minus 8x to the power minus 8 minus 1 minus 9. So students, I get the answer d square y upon dx square is equal to 7 into 8, 56 upon x to the power 9. I am using the law of indices over here, which is a raised to minus m is 1 upon a to the power m. Okay, so that was our question number 1. Now question number 2. Again, it is asking us to find the value of d square y by dx square. The first question says y is equal to e to the power x. When we differentiate this with respect to x, derivative of y is dy by dx and derivative of e raised to x is e raised to x itself, so no change. When I want to find the second order derivative, I have to say again differentiate with respect to x. So the second derivative of y, which is d square y by dx square, and derivative of e raised to x is e raised to x again. So that is your answer, guys. Let us understand the sum number 2. It's a similar sum. I have y is equal to e to the power 2x plus 1. So when we want to differentiate this, I have to write over here differentiate with respect to x, and I use the formula e raised to fx, which is e raised to fx itself and multiplied by derivative of fx. So students, again this is a part of composite function. You can check out the link for understanding all the different types of composite function given there in the description box. Derivative of y dy by dx e to the power 2x plus 1. So I consider this entire term as my fx. So this will be e raised to 2x plus 1 multiplied by derivative of 2x plus 1, which is e raised to 2x plus 1 multiplied by 2 into 1, because 2 is the coefficient and derivative of x is 1. So I get 2 into 1. 1 is a constant, so the derivative is 0. So the answer is 2 into e raised to 2x plus 1. But this is your value of dy by dx. Since we are interested in second order derivative, I have to say over here again differentiate this with respect to x. Derivative of dy by dx is d square y by dx square, or you may say second order derivative of y is d square y by dx square. Now this 2 is the coefficient, and once again e raised to 2x plus 1, as we differentiated in the first case, it becomes the same, 2 into e to the power 2x plus 1. So final answer comes out to be 4 into e to the power 2x plus 1 is equal to d square y upon dx square. So students, that was the sum number 2. Now let us understand the sum number 3. Okay. So the sum number 3 over there is y is equal to e to the power log x. Always remember guys, in case of calculus, if nothing is given to us in the base, then the base is always considered as e. Now there is a very important property of logarithm, which is like this: a to the power log x to the base a is always equal to x. Whatever value is inside log comes as the answer. Students, this is a part of the properties of logarithms, for which I have made a separate video. You can see the link over there on the top right corner as well as in the description box. For understanding this particular property in detail with more examples, please check out that link. so that it becomes very clear in your mind how to apply this particular property. Let us continue this over here. So because this over here E and E are same, I can directly say y is equal to x. Now when I differentiate this with respect to x, you get derivative of y dy by dx and derivative of x is equal to 1. Because I want to find the second order derivative, I have to say over here again differentiate with respect to x. So derivative of dy by dx will be equal to d square y by dx square, and derivative of 1 will be 0. So that completes your exercise, guys. Thanks for watching.